This problem and all other CALC 152 problems can be found here at Sarai Studies. Link is in the description box below. We're told to find the arc length of this curve from 2 to 3, and the formula for arc length I denote it as L, and it's always going to be the integral from A to B, and it's always going to be the square root of 1 plus, and then the difference lies here. If your function, if your curve is in terms of x, the terms contain x, then your integral should also be in terms of x. They should be the same terms. So it would be f of and then x, and you're doing the derivative of f of x, and you're squaring that, and then every integral needs a d, and then whatever the variable is. So if you see x in your curve, then x should be everywhere here. So including the bounds, if you saw y, then it would be y, y, and then y equals y equals. Here they give us our bounds, so it's from 2 to 3, so x is equal to 2, and b is equal to 3. Now we want to work on the side. So it's going to be, first identify our f of x, that's just what they give us, 2x plus 1 to the 3 halves. We want f prime of x, so take the derivative of that, take this to the front, so that's just 3 halves, leave the 2x plus 1, subtract 1 from this, so 3 half minus 1 over 1. Common denominator 2 is just 1 time, so 3 times 1 is 3. Here we have to go times 2, so 2 times 1 is 2, and then we have 1 half. So this here is 1 half, and then we multiply because of chain rule. The derivative of the stuff on the inside, derivative of a constant is 0, derivative of 2x is just 2. And then we have to square this. So now we have to find f prime of x squared, which is all of this squared. So that's 3 halves, 2x plus 1 to the 1 half, and then this times 2 can be brought up here, so this could be a 6, because 3 times 2 is 6, and then divided by 2 is 3, so we can simplify our answer like so, and then we have to square this whole thing. So when we square this, this becomes 1 half times 2, which is just 2 over 2, the 2's cancel out, right, so it becomes 1, so this goes away, and then when we square this, this is just 9. So we have this as our f prime of x squared. We can simplify this further. This can be 18x and then plus 9. And then we also have to add a plus 1. So f prime of x squared plus 1 is going to be 18x plus 9 plus 1. So that's just 18x plus 10. So once you finish simplifying everything inside the square root, you want to plug it into your formula. So we have the length of this curve is from 2 to 3 of the square root of 18x plus 10, and then don't forget your dx. And then you would just have to solve this integral, find the antiderivative. So let's try u sub. Remember, cup for u sub. C is what we care about. I care about my u, my du, and my dx. I'm going to make whatever's on my inside, the whole thing, my u. The du is the derivative of this, which is just 18, because derivative of a constant is always 0. Derivative of this is just 18, and then times dx, whatever I see here. And then dx is just taking this and solving for dx, so it's always going to end up being du divided by whatever's next to dx, so it's 18. And then our u part in cup is to put everything in terms of u, which should remind you, hey, our bound should also be in terms of u. So right now I have x is equal to 2 and x is equal to 3. So I have to find the u equivalents of those. So I have my equation u. So 18 times 3 plus 10, 18 times 2 plus 10. So 18 times 3, that's 24, 3, 5, 54, plus 10, that's 64. 18 times 2 is 36, then plus 10, that's 46. So then our formula becomes the length is equal to u is equal to 46 to 64, and then the square root, and we made this our u, so it's u, and then dx is now du divided by 18, and then we can bring out this 18, because this is really 1 times du over 18, so we can bring out the 1 over 18 like so, then get rid of this, and then we're just left with this being du, and then this is beautiful because we can now rewrite this as u to the 1 half, and now we can use power rule. So find the antiderivative of this is just plus 1 to the exponent, so that's 3 halves, because 1 half plus 1, common denominator is 2. 2 times what is 2? Well, 1, so 1 times 1 is 1. 1 times what is 2? 2, so 1 times 2 is 2, so that's 3 halves. So here we have, let me move this over. So we have u to the 3 halves, and then whatever this is, we divide by that. So it's divided by 3 halves, or when we divide by a fraction, that's the same thing as multiplying by the reciprocal. So it's going to be times 2/3. This is all multiplied by 1 over 18, and it's being evaluated from 46 to 64. And then you can simplify this further. So take this 2/3 out, so that's 2, and then 18 times 3, that's 54. And then this is u, so the 3/2, so valid from 46 to 64. And then our b part in CALC is to plug our u back in, but since this is a definite integral, we have our u's. We literally solved for u's. These are u's. We're plugging those u's back in. So that's fundamental theorem of calculus. We have 2 over 54. And then you take this, plug this in, so 64 to the 3/2. And then minus, take this, plug this in, so 46 to the 3/2. We can simplify the 2 over 54 to be 1 over 27. And this is equal to the length, the arc length of our curve right here. This can be simplified further, but they won't give you such hard numbers. Like, they might give you something like this where you do have to do some simplification, but the numbers will not be that hard, because if you take 64 to the 3rd power, that's a really large number, and then they expect you to square root that. That's not going to happen. So the numbers are going to be easier. But yeah, this is our answer. Just know that if you have a calculator, this becomes 512. But that's really it. This is the arc length of this curve from 2 to 3, and that's it for this video. I'll see you in the next.